Okay, thank you. Well, thank you for your patience, everyone. I understand it's a new system, and there's always a few bugs that take place when there's a new system, and we can all handle that just fine. That's not a problem. All right, I'm going to talk about getting evolution right. It's that is a title with some hubris, but basically what I want to talk about is communicating evolution to the public in a way that doesn't exacerbate the misunderstandings that the public has about evolution already. And writers and journalists and other people who bring science to the public are in a very good position to do this or to further screw things up. So I've got some thoughts about this. Now, a New York Times reporter at a meeting that I was at once said there are only 5 science stories. It's going to kill you. It's going to cure you. Mad scientist. Bad scientist. Or anything having to do with abortion or religion, which means this Canadian newspaper reporter must have thought he died and went to heaven when this story came out. But certainly the creationism and evolution controversy, which is what I deal with mostly in my day job, is very often in the news. In my experience, the way that this controversy is covered and the way that evolution is covered often exacerbates the controversy or confuses the public about evolution. Now, I'm going to talk mostly today about writing about evolution more than writing about the creation and evolution controversy, since this audience is much more likely to be writing about the science than writing about the social aspects. But a lot of what I'm saying will apply to either, of course. The outline of my comments are that I want to look first, I'm sorry, we're still doing just a slight tweak here. I want to look first at the nature of the American media and how it affects the coverage of evolution, and in some cases, science in general. And then I also want to talk about the language that we use, which affects what we are transmitting. And really, I think it's an important principle that one knows if one is a teacher, and I suspect journalists appreciate it as well, which is what they hear is a great deal more important than what you say. And it's that disconnect, because unfortunately, when it comes to evolution, your audience is not a tabula rasa. Your audience already has a lot of misconceptions and understandings and misunderstandings about what evolution is. I'm going to talk mostly about biological evolution, but I would like you to keep in your peripheral vision, as it were, this idea that evolution actually is a concept that undergirds all of science. It's not just evolutionary biology. The big idea of evolution is that the universe has had a history. If we were to go into the past, we would find that galaxies are different from what we see today. Stars are different, which is why astronomy is an evolutionary science. The planet Earth has certainly changed cumulatively over time, so geology is an evolutionary science. We all know that biology is an evolutionary science, and I would argue that my own field of anthropology is also an evolutionary science. In all cases, you are dealing with the idea of cumulative change through time, which is the big idea of evolution. But I'm going to be talking today about biological evolution because you can only talk about so much in any one presentation. And the definition of biological evolution is common ancestry. The idea that living things shared common ancestors, they have descended with modification from common ancestors. Common ancestry really is the big idea of evolution. And although that seems like a very simple concept, it's one that is very much misunderstood. What I mean by it is basically simple genetics. I like to think of evolution, and I often teach about evolution, using the analogy of a human pedigree, because everybody understands that kind of descent with modification. So my sister Sue and I are the children of my father. Dad is the child of Grandpa. Grandpa is also the father of Uncle John. Uncle John is the father of Cousin Liz. Sue and I look more like each other than we look like Cousin Liz, because Sue and I shared a common ancestor in Dad, more recently than we shared a common ancestor in Grandpa with Cousin Liz. That basic principle is what evolution is all about. The more recently you shared a common ancestor, the more similar you are. You probably had taxonomy in 7th grade or in high school or something like that, and they taught it totally backwards. They taught you that we class mammals together because all mammals have the same characteristics. All mammals have hair, and they have a single bone in the lower jaw, and they have warm blood, and so forth and so on. No, the reason we classify all mammals together is not because they have this set of characteristics. They have this set of characteristics because they descended with modification from a common ancestor. So classification is something that is understood much more clearly if you understand the idea of common ancestry. Works the same way with other organisms. Bears and dogs look more like each other than they look like lions, because bears and dogs shared a common caniform ancestor with one another more recently than they shared a common carnivore ancestor with the cats. And Cebus and howler monkeys look more like each other than they look like apes, because Cebus and howler monkeys shared a common monkey-like ancestor with each other more recently than they shared a common primate ancestor with the apes. But bears and monkeys look more like each other than they look like salamanders, because bears and monkeys shared a common, bears and monkeys and carnivores and primates shared a common mammal ancestor with each other more recently than they shared a common vertebrate ancestor with salamanders. So the whole idea of evolution, this descent with modification, is a branching and splitting tree of life through time. And common ancestry and this genetic relationship of species through time is really what evolution is all about. Now, I'm going to do something right now that sounds a little bit like a digression, but actually it is quite relevant to our discussion this afternoon, and also relevant to Matt Nisbet's comments this morning. I want to talk, just as a little footnote here, a little bit about the nature of science and the content of science as scientists view it anyway. And I stole this idea, by the way, from a local guy around here, a physicist named Jim Treffel. Some of you may know him. He does a lot of good science outreach. He's a very good science communicator to the general public. Many, many years ago, back in the 70s, he wrote an article called The Consumer's Guide to Pseudoscience in something like Harper's. And he had this great diagram which stuck in my mind, and I've used it in my own college teaching. I put it in my book, and I find it very useful for helping the public understand kind of the gradations of certainty that we have about scientific explanations. Jim pointed out that in science, when we look at the content of science rather than the method of science, we have the core ideas of science, the ideas that have really stood the test of time, the ideas that have been tested so many times. Scientists feel very confident that they work. You know, that the planets go around the sun is an idea that's here to stay. You know, heliocentrism is pretty firmly established. We're not actually actively testing the idea of heliocentrism versus geocentrism anymore. There's a lot of confidence within the scientific community about a lot of things. Laws of thermodynamics, Mendel's rules of inheritance, evolution, heliocentrism, so forth and so on. Next to the core ideas of science are the frontier ideas of science, which is really where the kind of research at HHMI is going on, the kind of research going on in other institutes and universities and businesses, pharmaceuticals, et cetera. Frontier of science is where ideas are actively being tested, hypotheses are being generated, explanations are being proposed and tested, and this is where the real ferment of science goes on. Generally speaking, the core ideas of science may encourage or stimulate new hypotheses in the frontier. If you're really lucky, you've got a good explanation, it might go into the core someday. The unfortunate news of most science is that most of the ideas you come up with don't work, but you know, you do the best you can. So the frontier of science is really where the action is. Jim points out that there's also the fringe, the outermost limit here. The fringe ideas of science are the ideas that real scientists really aren't spending any time on. They're ideas that, generally speaking, are being ignored by science because they violate some core principle. My favorite example is perpetual motion machines. These days, this is known as free energy. If you get online, you Google free energy, you will get lots of websites that offer you wonderful investment opportunities to invest in these new products that will solve our energy problems. No more oil spills. Free energy is the answer. Credit cards accepted. And of course, when you really examine these free energy opportunities, the gadgets that they're talking about are all perpetual motion machines, which of course violate the core concept of the laws of thermodynamics, which is why real physicists don't invest in free energy opportunities. There's a very good reason for this. Now, what does this have to do with evolution? Evolution is a three-part idea, biological evolution. There's the big idea of common ancestry, and then we explain and explore this idea of common ancestry by discussing the mechanisms or factors or processes that effect, not affect, effect meaning bring about, as we just discovered in our grammatical lesson here. I'm using this word correctly, Don. The processes that bring about evolution, natural selection being the most important, but there's a variety of other ones. And if this was a lecture on evolution, we'd be talking about that sort of detail in more time. Also, we talk about the pattern of evolution. How does this wonderful tree of life branch through time? There's a little bird phylogeny here. Big idea of evolution and pattern and process. Those are the three parts of this idea of evolution. Now, the big idea of evolution is a core idea of science. Scientists are not arguing over whether living things have common ancestors. Pattern and process are the frontier ideas of science. We argue like cats and dogs about how the tree of life branched. We argue a lot about the power of natural selection versus other mechanisms to establish body plans. We argue a lot, it's normal science to argue about the frontier areas of science. And in evolution, that's the pattern and process. I bring this up as a useful thing for you to keep in mind because many times, lots of times, anti-evolutionists will propose that because scientists cannot agree upon the power of natural selection, say, or because scientists are arguing over whether birds and dinosaurs have a common ancestor, therefore, evolution didn't take place. This is a category error. You are confusing the big idea of evolution, which is a core idea of science that we're really not debating, with the frontier ideas of science, with the frontier ideas of evolution, the pattern and process kinds of arguments. And that's a very useful thing for the public to understand, and it doesn't actually understand it. And that's nature of science, helping the public understand that science really is this very active and in some cases adversarial process where ideas do have to be tested and positions are taken and refuted and rearranged and reconsidered and so forth. And gradually our understanding of the natural world does lurch forward. So I'm going to be referring to evolution in this sense, the big idea of common ancestry, but also the pattern and process. Now, let's talk about narrative. Let's talk about telling stories, because that is what a journalist needs to do. And that makes an interesting story. I'm not complaining about storytelling as part of journalism. We learn through narrative. A good teacher will teach through telling stories. That's one reason why history is such a great way to teach science. People remember the details better if you can hang it on a narrative. And there are lots of stories outside of science, just sort of in general. The hero narrative is a very common kind of story that you run into a lot. The hero sets out on a quest, overcomes obstacles, eventually triumphs over adversary. You know the story. Sometimes kind of a subset of the hero narrative is the coming-of-age story. The youth sets forth, oftentimes on a quest, overcomes obstacles, and eventually triumphs over adversary. Conflict is a common narrative. Let's you and him fight. And conflict is a very easy narrative, and it catches the reader's eye, and it's something that's very attractive for journalists to use. In the case of evolution, there are lots of these narratives, and all three of these kinds of narratives are really quite common, especially the hero tale. The Australopithecine ventures out onto the savannah, learns to make tools, learns to hunt, and overcomes obstacles of becoming the saber-toothed dinner and triumphs over adversity. And you'd be surprised how many descriptions of human evolution take this hero sort of narrative. Now, I'm not knocking it. Like I say, we learn through narrative, and if you can hang an understanding of what happened in human history on a story, I'm not going to complain. Some physical anthropologists harumph a bit about hero tales, but hey, that's not a real problem. That isn't a real problem. Just be aware of what you're doing. Be aware that you are spinning one of these hero tales, and be careful that you don't overstep the actual science. That would be my suggestion here. Now, unfortunately, conflict is a particularly popular theme in the coverage of many science stories, not just evolution, but especially in evolution. Highlighting the personal differences and backbiting that take place among paleoanthropologists and paleontologists is an easy way to write a story, and these squabbles sometimes overshadow the actual scientific story. I think more has been written about the Johansen-Leakey personality dispute than perhaps the science deserves, or arguments between Steve Gould and just about anybody else. The conflict narrative is one that is very, very popular. You find it all the time in print journalism. You find especially in videos and movies. Let's You and Him Fight is a great narrative to hang your story on. Be careful of it because journalists tend to like it because it's real easy and it's very attractive to readers. But let me give you an example of a conflict narrative that went very, very wrong. January 24th, 2009, the New Scientist had an article by Graham Lawton. The cover was "Darwin Was Wrong, Chopping Down the Tree of Life." Now, actually, the article was pretty good. It concerned research about lateral gene transfer among the 3 domains of life. Remember the 3 domains of life? Eukarya, bacteria, and archaea. You are here, we are eukaryotes. The issue has to do with, is there a last universal common ancestor, LUCA, L-U-C-A. And the article by Graham Lawton was talking about research, fascinating research that's being done about how genes are swapped around among bacteria, archaea, and eukarya, but way down here at the bottom of the tree of life, right? So there's the spaghetti at the bottom of the tree of life that is going to make reconstructing LUCA kind of difficult. Now, does this mean evolution didn't occur? This is how many members of the public looked at that New Scientist cover. Darwin was wrong. The tree of life has just collapsed because of lateral gene transfer, whatever that is. Well, there's a very important point here, is that all this lateral gene transfer stuff takes place at the single-celled organism level. It's with bacteria and archaea, these little, I'm an organismic biologist, so sorry for you cell biologists and biochemists and all that, but up where the really interesting science is. Okay. With metazoa, with multiple-celled organisms, nobody argues. See that little arrow up there? Nobody argues that you get trees from there on. It's just kind of an interesting thing that there was all this swapping around back in the very early days of life, back 3.5 to 8 billion years ago. But nobody in evolutionary biology is arguing that the tree of life has somehow gotten chopped down. The roots just gotten more complicated. It's a little more spaghetti-like. But there is a definite tree once you get multicelled organisms. But the cover, Darwin Was Wrong, Chopping Down the Tree of Life, was a real disappointment, shall we say. For starters, Darwin didn't know anything about genetics, so how can he be wrong, right? And certainly the tree of life has not been chopped down. Now, journalism has consequences. At the Texas Board of Education meeting on January 26, which I was attending, Chairman Don McElroy held up a copy of the New Scientist article from the web saying, look, scientists say Darwin was wrong. Scientists say there's no tree of life. Can't we tell students about that? Why can't we present the weaknesses of evolution as well as the strengths of evolution? Now, we were in the middle of this huge fight about the Texas Texas Educational Knowledge and Skills, the TEKS, T-E-K-S, the standards in Texas. And this did not help, to say the least. The editor of New Scientist was roundly criticized by the scientific community, and properly so. I'm trying to find here what happened to my cursor, because I have a lovely quote to read to you, if it can only be found. Ha, here we go. And I quote a letter from Dennett, Dawkins, Coyne, and Myers. "You have made a lot of extra unpleasant work for the scientists whose work you should be explaining to the general public. We all now have to try to correct all the misapprehensions your cover has engendered." And they were right about that. Showing, if you don't mind my saying so, his utter cluelessness, Highfield defended himself by saying in an editorial, by saying that, well, it's okay because in an editorial accompanying that article, he said that creationists were likely to take this out of context. None of this should give succor to creationists whose blinkered universe is doubtless already buzzing with the news that New Scientist has announced Darwin was wrong. Expect to find excerpts ripped out of context and presented as evidence that biologists are are deserting the theory of evolution en masse. They are not. Speaking of blinkered, and he thought, well, because I pointed this out to people, it's okay. Here's your silver platter. And this is not a useful thing. Now, adding insult to injury, even after scientists gave him evidence that harm was being done, Highfield then used the cover proudly in a promotion to get people to subscribe to New Scientist. Yeah. This is just injury to injury. Now, I am not so naive. I'm an ex-college professor, right? I've recovered. I'm not so naive as to not understand that y'all have to sell magazines, and that this is a business, and clearly you are trying to interest people into purchasing the magazine. So having a cover that attracts the public is a good thing. That in itself is not a bad thing to do. But I suggest that there are more responsible ways to get the public's attention than by a cover like Darwin Was Wrong, chopping down the tree of life. And it was done a couple of years ago by National Geographic. Notice the difference. Was Darwin wrong? Now that's still going to get somebody to pick up the magazine, right? Gee, was Darwin wrong? Well, I don't know. What does National Geographic say? And of course, you turn to the proper page and you find no. The difference is Darwin was wrong is a flashy cover to get people to buy the magazine. As to, was Darwin wrong? I think there's a big difference in terms of communicating science to the public. One is responsible, one is completely irresponsible. Let's move along to the idea of balance. Narrative and the need for conflict can skew the accuracy of reportage, affect the public's understanding of an issue, but I think the idea of balance is perhaps the most difficult in terms of the nature of American journalistic approaches, to deal with in a scientific context. There are science stories where there are legitimate differences of opinions among partisans, the frontier ideas of science, right? Work in progress, the jury's still out. It's perfectly appropriate to say laboratory A says this, laboratory B says this, scientist A says this, scientist B says that, when it's a frontier idea of science, when it's an area of science where legitimate discussion and testing of explanations is still going on. But there are many settled issues in science, like evolution, like vaccines work, right? That really don't need to be treated in this balanced sort of fashion. Well, here's what Professor so-and-so from the university says about this new human fossil. Here's what the Institute for Creation Research says about it. This is not balance. You talk about balance when you actually have legitimate differences of opinion within the science. Nobody really gives equal time to the geocentrists within the creationist movement and the heliocentrists, because heliocentrism and geocentrism are decided issues. Sometimes the urge to balance a story will be influenced by the inclination to stress conflict. Again, conflict is a good narrative to use. And a story will be presented that's really not a conflict, except in the most trivial sense. The link between birds and dinosaurs, for example. Within paleontology, the argument is over whether birds and dinosaurs shared a fairly recent common ancestor or whether birds and dinosaurs shared a more distant common ancestor and had a longer period of time of separate evolution. The difference of opinion here is treated as a defeat for evolution. Many members of the public misunderstand the nature of science. And again, this sort of three concentric, or at least two concentric schools, nature of science. If scientists are debating the details of a field, if scientists are debating the frontier areas of science, in the case of evolution, pattern, and process, then evolution must be an idea that has no legs. Evolution can't possibly be true. So what anti-evolutionists will often do is take something like the bird-dino dispute, which is a very minor one within evolutionary biology, within paleontology. And actually, by now, the preponderance of opinion is so strongly on the closer bird-dino link that it's not really much of a dispute anymore. But they'll take that as evidence against evolution being a valid scientific idea. And ironically, for creationists, there really isn't any story there. I mean, it's still evolution. It's just recent or less recent. Lawyers have a somewhat cynical statement about expert witnesses, which unfortunately falls much into this idea of balance that you find in journalism. For every PhD, there's an equal and opposite PhD. And so we have Michael Behe, the idea proponent, on one side, and Richard Dawkins, the evolution proponent, on the other. And oftentimes, in dealing with this issue, the press will present these positions as if they were both equally valid and equally supported. But of course, for every PhD, there's not an equal and opposite PhD. When you actually look at the number of scientists over here on the evolution side, and the paucity of scientists over on the intelligent design side, it simply becomes absurd to try to equate these as both being appropriately balanced and weighted. Now, in controversies over the teaching of evolution, as opposed to controversies over what is science, the press properly will present the different points of views. If there's a school board level a dispute, or if there's a dispute at the state legislature over whether anti-evolution legislation should be passed, it's perfectly appropriate for the journalist to say, this side says that, this side says that. What would be responsible journalism, I would argue, is if the press were to say, this side says this side says that, but the second side is not viewed by the scientific community as having any merit. If you don't, you run into this, for every PhD, there's an equal and opposite PhD kind of communication, which I think you want to avoid. I'm saying you in the very broadest sense of people who write about science. You may or may not be specifically writing about this in your own magazines, but it's a good thing to keep in mind. When you have a controversy over vaccination, or HIV/AIDS link, or global warming, or evolution, anything that is socially controversial, it's a very useful thing if you, obviously, social controversies, you need to present the views of the contending sides. But it does a great favor to science and to public understanding of science if you distinguish between which is the position that is supported by the majority of science. So presenting the anti-vaxxers as if they have equal support as the standard medical profession's views on vaccination simply is doing great harm, I think, to society. I firmly believe in the Groucho Marx school of plagiarism, steal only from the best. At its worst, balance can degenerate into squirrel journalism, a nut on one side and a nut on the other. I thought that's a great line. I'm going to steal it. Isn't that a wonderful cartoon? It's called squirrel fishing. You can you tie a nut to a string, and you torture little squirrels, I guess, in one sense. But no animals were hurt in the making of this photograph. But a nut on one side, a nut on the other, and that's what you want to avoid. I'm really glad that we're here at HHMI, and that obviously, in a lot of the talks that I give. Public talks, there's always a creationist there, and they're taping me. I'm glad that nobody here is taping me for later transcription and putting things on the web, because I have a confession to make. And I will confess this to you because you are all my dear friends here at IRMA, and that is that I do not believe in evolution. This will come as a real shock to the creationist community. They would like to hear this, but let's just keep this as our own secret. I'll tell you some things I do believe in. I believe in evolution. I do not believe in, I do not believe in evolution. I don't believe in thermodynamics. I don't believe in heliocentrism. I don't believe in plate tectonics. I don't believe in cell division. I don't believe in atoms. And I don't believe in the kinetic theory of matter. I'll tell you what I do believe in. I believe in free speech. I believe in the separation of church and state. I believe in taking steps to curb global warming. I believed in regime change in November 2008. And I believe that my husband is the smartest, funniest, and best-looking man I know. Now, boys and girls, what is the difference between these two columns? Well, clearly, one set of these are opinions and the other aren't. Where you want balance is when you're talking about opinion. That's fair. It is not a matter of opinion whether the earth goes around the sun or the sun goes around the earth. And I think that is a useful thing to keep in mind. So I'm talking now, obviously, about watching your language. And the first point that I have just made, I hope, is that you don't believe in evolution any more than you believe in cell division. It's very interesting because you would hardly ever find a scientist saying, yes, I believe in atoms. But even scientists, because they're members of society, will sometimes sort of fall into societal communication. And you will find them talking about, well, gee, so-and-so doesn't believe in evolution. That's the wrong word. The word belief is not really part of science. We don't believe ideas, we test them and we accept them or reject them. So I much prefer referring to one's acceptance or rejection of evolution. Because, frankly, belief has these extra material, if you will, components to it. I don't believe in evolution because if 2 weeks from now somebody comes up with really good explanation that would tell me why there's so many different kinds of organisms out there that doesn't rely upon common ancestry, that will be really interesting. Evolution is not a belief. It's something we accept because it really explains nature very well. Let's see now, I've talked with some of you. Are there any Lyellists here? No. Let's see now, you're a Calvinist, aren't you? No, Kelvin, Kelvin with a K. There's not Calvin, no, Kelvin. Are there any Darwinists here? Good, you didn't get caught. Evolutionary biologists are no more Darwinists than physicists are Kelvinists, okay? Think about the word Darwinism. What does the word Darwinism mean? Well, it's a very ambiguous term. Does it refer to Darwin's ideas back in the 19th century? Yeah. Historians will talk about Darwinism, the idea of evolution through natural selection, Darwin's view on this, that, and the other. That's Darwinism, but that's not evolutionary biology because evolutionary biology today has gone so far beyond what Darwin talked about. I mean, we might be Dobzhanskyists as much more than we're Darwinists in the real sense of the term. But Dobzhansky is hard to pronounce, so nobody's really fallen into that particular trap. And, really, there are so many aspects of evolutionary biology today that are non-Darwinian. To use Darwinism as a synonym for evolution is very misleading, because that's, it ties this very important scientific idea to a 19th century set of ideas that were largely right, but not totally right. Certainly Darwin didn't get it right when it came to heredity. And so you should really talk about evolutionary biology. It's a little bit longer, a few more syllables, but calling it Darwinism really misleads people. There's another good reason to not refer to evolutionary biology as Darwinism, not only because that's not the science that we're doing today, but also because it's an ism. What are isms? We just had this wonderful word, exercise here about editing. Isms are ideologies. And we don't want ideologies taught to our students in school, now do we? This is improper. Creationists contend that Darwinism is an atheist ideology masquerading as science. And of course, we don't want this sort of thing to be taught in school. The Discovery Institute proponents are almost comical in this. If you read the creationist literature, I refer off and on here in this talk to the creationist literature because so much of it is out there and it has influenced the public thinking about this subject. But if you read the creationist literature, you find Darwinism as an epithet. You can kind of see the lips curling over the teeth there. A press release from the Discovery Institute. The Discovery Institute has filed a public records request with the Ohio State University seeking all documents related to Darwinist attacks on OSU doctoral candidate so-and-so. In June, so-and-so's dissertation defense was suddenly postponed after the Darwinist professors at OSU attacked. It just goes on and on. Darwinism. Help, help, the Darwinists are coming. This is not accident. This is a deliberate attempt to demonize evolution by tying it to an ism, by tying it to a character from the 19th century whom you have accused of racism and so forth. Of Pandas and People is a quite famous book in my line of work. This was the book that was proposed in Dover, Pennsylvania, and has shown up elsewhere over the years as a intelligent design book. And OPAP, as we call it, came out in 2 editions, and when we were preparing for the Kitzmiller versus Dover case, we were, of course, examining these very carefully. We hadn't looked at this book in a while, and we came across something very interesting, that the first edition and the second edition had some very consistent changes from one to another. For example, we found that there were no ideal parts available, so evolution fashioned and remodeled existing parts. Other paragraph, there were no ideal parts available, so Darwinian mechanisms fashioned and remodeled existing parts. One goal of evolutionists is to trace, one goal of Darwinists is to trace, and you can follow this all the way through the book. They basically took out the word evolution, evolutionist, replaced Darwinism, Darwinist, because demonizing Darwin is a useful thing if you want to get evolution out of the classroom. So, please do not refer to evolutionary biology as Darwinism. It misleads the public and it exacerbates a problem that we already have. Another thing that I would, okay, we'll move on here. Theory of evolution. Well, of course evolution's a theory. Sometimes we have this thing about, is evolution a theory or a fact? Well, evolution's a theory because theories are so much more important than facts. Theories explain facts. Of course, that's not necessarily how the public understands the word theory. On the street, the word theory is a guess or a hunch. That's your theory buster, and is something that you don't have to pay a lot of attention to. Mm-hmm.
They'll say, well, my theory about this is, and what they're talking about is their frontier experiment.
Hypothesis.
It's a hypothesis.
Yeah.
And if I quote the person correctly, it's going to be used as a German.
You have to quote people correctly. I mean, unless you can just paraphrase that section or something.
Or we quote it if that's okay, or you recommend bringing it up to them. get them to start?
It depends on context. It really depends on context. I mean, you can have higher level theories and lower level theories. Basically, a theory is an abstract expression, an abstract explanation, an inferential explanation. And there's low level and higher level, but you know, explanation is really what science is all about. That's what we're trying to do. So formation of theories is really the goal of any scientist. I bring up theory of evolution because it's interesting how the only time you get the phrase theory of is with the E word. People don't talk about the theory of cell division, although you could, because there's all sorts of inferential explanations that are involved in explaining how cells divide. Virtually anything useful or important in science is a theory. But the only time we, pardon? Theory of gravity. Theory of gravity, yeah. You know, gravity is an inference. It's not an observation. Things falling is an observation. You explain things falling by the theory of gravitation. But, so my suggestion to you is to don't talk about theory of evolution, okay? Because unless you talk about theory of evolution and all the other theories too, unless you're talking about the theory of this, the theory of that, the theory of this, and just clutter up your article with theory of phrases all the way through, the tendency is that you're only going to use theory of along with evolution, which sort of puts the neon lights around evolution and sets it aside in your reader's mind as something that's different from everything else. So just talk about evolution. You save 2 words that way. You can talk about relativity. Yeah, in fact, probably most of you do. You don't write theory of relativity. You don't have to say theory of evolution. Evolution, or evolutionary biology, gets the job done just fine. Man evolved from monkeys. This is a very common idea about evolution. In fact, it's probably the idea that's in most people's mind when you ask them what is evolution. Evolution is man evolved from monkeys. And of course, there's so many things wrong with that phrase, starting with man. I mean, clearly females had to be involved there somehow, but you know, I mean, the phrase that you fear from the public is man evolved from monkeys, so we'll work on that. And of course, those of you who are sharp-eyed will recognize that that is not a monkey. This is a monkey. That is an ape. But man evolved from apes, man evolved from monkeys, it's still wrong, okay? Remember what I was saying before, what they hear is more important than what you say? If you say humans evolved from monkeys or humans evolved from apes, what the public hears is that humans evolved from chimps. They don't think humans and chimps had a common ancestor, which of course is the actual relationship here. Humans and chimps had a common ancestor. More distantly, monkeys share a common ancestor with the common ancestor of humans and modern-day apes. But to say humans evolved from apes may or may not be technically true. I mean, I can go round and round on this with physical anthropology friends of mine. The common ancestor of humans and apes did not have the derived hominine traits of bipedal locomotion, a large brain, dependence upon tool-using culture, didn't have those derived traits, clearly. But the common ancestor of humans and modern apes also didn't have the derived characteristics of modern apes. They didn't have the big teeth, they didn't have the knuckle walking and other characteristics. The common ancestor of humans and modern-day chimps probably looked more like a quadruped apoid creature than it looked like a modern human, certainly. But it wasn't identical to a chimp. But more importantly than that, you know, whether you call that common ancestor an ape or what, it's not useful. I just would prefer referring to it as the common ancestor, a primate common ancestor. And don't link it to any particular living group. One of the big problems with humans evolved from apes or humans evolved from monkeys is that it exacerbates this kind of great chain of being idea that's in most Americans' minds when it comes to the idea of evolution. you know, quite often when I go on an AM radio show, you don't get it on NPR, but a lot of times on AM radio shows, someone will call up with a question for that evolution lady. If man evolved from monkeys, why are there still monkeys? That'll get her. And of course, what that represents is this idea of the great chain of being, that very simple organisms like worms evolved into more complex invertebrates, and they evolved into simple vertebrates, which evolved in, like fish, which evolved into amphibians and reptiles and primitive mammals and more advanced mammals, and then you get the primates, and then of course, ta-da, at the end, naturally humans are, at the very top of the great chain of being. From the simple to the most complex, from the sacred, from the profane to the sacred, however you want to rank them. This is basically a religious idea, comes from the Middle Ages. But whenever you hear, if man evolved from monkeys, why are there still monkeys? That's the concept that people have, that all monkeys would have evolved into humans, but since there are still monkeys, evolution couldn't possibly have taken place. People don't get the idea that evolution is about common ancestry. They don't get the idea that it's about a branching and splitting lineage, like my or your family tree. They have this idea that there's this great chain of being where things march in a progressive, stepwise fashion to greater and greater complexity. And of course, it's not true that fish evolved into amphibians, evolved into reptiles, evolved into mammals. An aquatic vertebrate gave rise to the first tetrapod, the first land vertebrates. Land vertebrates branched into two branches. One group led to modern-day amphibians, the other group led to amniotes. Amniotes branched into reptiles and mammals. Reptiles are not the ancestors of mammals. I mean, this is the whole branching and splitting thing, getting away from the great chain of being. If this were an evolution lecture, I'd go on about that because it's really fun, but I'm not going to talk about that today. Another thing that you should be careful about in talking about evolution is this phrase. Somebody discovers some new fossil or some new discovery of whatever, some new dating or whatever, and this changes everything we know about human evolution. This is the sort of thing that sends me screaming from the room. Number one, it's just not true, okay? If you discover some new Australopithecine, some new fossil, these early ape men, if you will, back from 3 to 5 million years ago, that's just really cool. And this is a fascinating period of human evolution. Clearly, there was some sort of adaptive radiation of ground-living primates and bipeds, and there were big ones and little ones, and ones with larger brains and smaller brains, and some of them used tools and some of them didn't, and it's just this really wonderful spaghetti of adaptive radiation that's going on. That's really great. You find a new one that makes it more complex and more interesting. It has absolutely nothing to do with the relationship between Neanderthals and sapiens, or Erectus and Neanderthal. So to say, this discovery changes everything we've ever known about human evolution is just nuts. I mean, it's just simply wrong. And of course, what that does is communicate to the public that evolution isn't a real science because you guys are always changing your mind, which gets us into the public understanding of science just in general. Similarly, the discoverer of a new Neanderthal or this recent genomic analysis of Neanderthals, it was so cool, showing that non-African Homo sapiens of today share some ancestry with the Neanderthals. That was a really neat article. And sure enough, there was the obligatory, and this changes everything we know about human evolution. It doesn't tell us anything about Homo erectus, doesn't tell us anything about the Australopithecines. Human evolution is a long and complex process. Making one discovery is highly unlikely to change everything we ever knew. So please tune your ears to that and try not to use it yourself. And if you're talking with an overly enthusiastic scientist, don't use that quote, because it really doesn't help. While we're on the topic of human evolution, by the way, a meme that's out there in the public is that, human evolution reconstructions and our understanding of our species past is just based upon this tiny little fraction of fossils. I mean, you could fit all of them on one table. Well, no, that's actually not true. And marvelously enough, if you have time to go down to the Smithsonian's new human evolution exhibit, take a look at at a wonderful array that they have of just crania, much like this picture here. This isn't all of them, okay? I mean, this is just sort of reasonably complete specimens. There are more Ardipithecus individuals. This very early Australopithecine. There are more Ardipithecus individuals than there are Tyrannosaurus rex. All right? The idea that the human fossil record is skimpy is just simply not true. Now, it'd be lovely if we had more, and it would be lovely if we had more complete specimens. And this is a bunch of crania, and there's more out there, of course, and we'd love to have more material, and the more material we have, the more we're going to know. But we do understand the basics of human evolution. We've got the big picture. We're really working on the detail. We got the core, okay? We know we stood up before we got big brains. We stood up. We started using tools before we got big brains. We got better tools as we got big brains. There's all sorts of things that everybody agrees on. But of course, the conflict narrative is the powerful one and the one that's very easy to write. So the press tends to stress the arguments among scientists about the details. And they sort of, and this is the fault of my colleagues as well, people tend to not stand back and say, well, wait a minute, this is just a little argument about whether Ardipithecus and Anamensis and Afarensis and what's the relationship among these guys. They're all bipeds, okay? They're all living on the ground. They all have these kinds of characteristics, and this is a really neat and important thing about human evolution. My Anthropus is older than your Anthropus. That's not as important as getting the big ideas across. Another kind of wording that you should be careful about is X is a mystery. I hate it when I see the word mystery in a science story. Quite commonly, the origin of life is one of these topics that seems to be associated with this phrase. The origin of life is a mystery. What people hear when you use a word like mystery when you're talking about science is this is unsolvable. We will never understand it. There are ways to deal with works in process. The origin of life is a work in process. It is absolutely correct that scientists do not have a consensus view on the steps going from inorganic molecules to organic molecules to something that can replicate to something that can replicate in a membrane. We got little bits and pieces of all of those, but we don't have a consensus view of the whole shooting match. That doesn't mean it's a mystery. But more importantly, when people hear the word mystery, what they take away is not that this is an unsolved problem, but it's an unsolvable problem. I encourage you to use the phrase, we don't yet understand, fill in the blank. And the word yet is a very useful one to use when you're talking about things that are not yet explained. Because if you talk about, well, we can't yet explain this color pattern in this group of fish, or we can't yet explain why this molecule functions the way it does. You leave in the reader's mind the idea that, well, scientists are working on this and maybe someday we'll know, which is a very different message than we'll never know because it's a mystery. So when it comes to watching your language, you don't believe in evolution, and Darwinism is not a synonym for evolutionary biology. Don't refer to theory of evolution, just refer to good old garden variety evolution. It gets the job done, and you don't need to clutter it up with additional phrases that actually only serve to confuse. The idea of humans evolving from apes needs to be treated carefully. If you've got time, you can develop the idea more fully. If you don't have time, refer to humans and apes as having common ancestors, because when people hear apes, they think of living apes. They don't think of an ancestral apes. Stress common ancestry in your discussion of evolution, and you will be doing a much better job of communicating it. everything we know about X is going to change. Try to avoid that kind of wording because it really does miseducate the public about the nature of science, as well as the strength of the science of evolution. And X is a mystery. Try not to use the word mystery. There are unsolved problems. Mystery communicates the wrong idea. And be careful also about narrative, and be careful about balance in the way that I tried to suggest to you. We are at ncsc.com. And there's some resources here that are very useful for journalists. If you go to this little button over here, you can sign up for a Friday e-newsletter that Glenn Branch puts out. It's very, if you know, I'm sure all of you are on Bob Park's What's New. It's sort of like that. It's just a series of bulleted points with lots of links. And, you know, some weeks you read it, some weeks you don't. But it kind of gives you what's going on in the creationism and evolution controversy that week. And yes, there's news every week, more's the pity. If you go to this button up here where it says News, you'll be taken to this page. And on this page, we have a lot of information about the creation and evolution controversy. You can sort by state or you can sort by year, find out what's going in your state or places that you're interested in. And journalists, I think, find this to be a very useful thing. It's also a membership organization, and clearly you are encouraged to join. ncsc.com. We are a nonprofit, but we were finally able to score ncsc.com, even though ncsc.org was taken by another organization. You could also find us at ncscweb.org, but that's a lot harder to remember than ncsc.com. My colleagues are Glenn Branch, who is the deputy director and does that wonderful Friday e-newsletter. Louise Mead is our education person. Robert Lunn is our communications guy. You may have had some correspondence with him already. Peter Hess is a theologian who is our faith community outreach person. And Josh Rosenau, Steve Newton, and Eric Mickle are the flare-ups wranglers, if you will. These are the people who get the calls, and me, of course, when somebody elects the wrong school board.